Like the third question, it's a little, it says challenge, but I would say it's a little higher medium question. Okay. Two horizontal forces. So horizontal means what? In the x direction, right? In this direction, hence x direction is horizontal. Forces are exerted on a large crate. The first one is 370 Newton to the right. The second force is 173 Newton to the left. So you can see here the directions are mentioned in terms of the right and left indications. And the part A question is asking you to draw a force diagram, right? A force diagram for the horizontal forces. Now you have to keep it in mind, the object we always refer to as a dot. So you can have place a dot in the middle so that's convenient for you to draw all the forces. And then if you look at this, to the right it's 317, to the left is 173. So you have to keep it in mind about the difference, or which is greater and which is smaller. Obviously this is almost like double to this number, so you show that this is a bigger force, 370 Newton to the right, and the other one keep it shorter because it is not, it's a very small amount compared to 370. Alright, so that's a very simple representation of the two forces that are acting horizontally on an object. So part A we have finished. Now part B, what is the net force acting on the crate? So for part B, how do we find the net force? You do the summing up of the vector addition. So here it is, to the right it is positive, to the left it is negative. So you combine them with the signs. So it is plus 317 Newton, negative 173. That will give you 144 Newton. And notice we got 144, positive 144. So what is the net force? Net force is to the right with an amount of 144 Newton. This is F net. Right, to the right. So we have done part B as well. So that's a complete solution. The answer to this question is, please note, write always units and also mention the direction if you are writing any vector quantity. Now coming to part 3. Part 3, yes, I would say little thinking is required. The box is initially at rest. So there is some information given here. So when it is initially at rest, we all know that the initial speed is 0 meters per second. And they give you here 5 seconds later. So 5 seconds represents time. And they give you its velocity is 6.5 meters to the right after this particular time. So V final is also given to you. What is the crate's mass is the question. Now, we don't see, okay, first let's write the formula. As always I say, even if you're not sure how to approach, how to continue, how to start the question, first write the formula that you know that connects the quantities in the question. So mass is asked and there is a force given to you earlier, net force is known to you, mass is the question. So what's the formula relating F net and mass? The triangle method is better, that's easier. So you have mass times acceleration. So to calculate mass, the formula would be F net over A. So now F net is already known to me. What is unknown? A is not known. So if I can find A from the other information given in the question, then I can find the mass. So take a minute to read the question, pause it, and try to understand what is asked and then proceed. Okay, so I repeat, mass is the question. We have F net, but we don't have acceleration given in the question. So let's find acceleration from the given information. For acceleration, last term we have learned this formula, Vf minus Vi over T. So we apply this rule here. Okay, so Vf is 6.5, Vi is 0, so we put 6.5 minus 0 over T is 5. So you get the acceleration to be 6.5 over 5. That gives you 1.3 meters per second square. Again, note the unit acceleration as a unit of meters per second square. So now I have acceleration. I also have so acceleration is known, F net is here, so all I have to do is apply this formula to get mass. Okay, so we can use that. So that is for part C. There are two-step calculation. First step, we found acceleration. Second step, we find m. So F net over A, that's equal to 144 over 1.3 equals is 110.8. If you round it off to the significant figures, 110.8, and the unit for mass is kilograms. Standard unit is kilograms. That completes this question.